everybody, and welcome back to Unit 6, Lesson 7, which is using antiderivatives to find exact areas. So in our last video, we focused on how to find and evaluate indefinite integrals using an antiderivative. And what we're going to do in this video is learn that we can use antiderivatives to find exact areas for graphs and functions that we couldn't find exact areas for in the past. So our learning targets for today, there are two of them. I can find the antiderivative of a function. Obviously, if you can't find an antiderivative, you can't use it to find an area. And then second part here is I can evaluate a definite integral using an antiderivative. So we're going to evaluate today, instead of indefinite integrals, we're going to be evaluating definite integrals. Here's what we know so far. We know that we can find exact areas using geometry. But the downfall of this is that it only works for geometric graphs that are nice semicircles, lines, rectangles, triangles, trapezoids, stuff like that. We also know that for graphs where we can't use geometric formulas, we can approximate the areas. And we can do that using RRAM, LRAM, MRAM, or the trapezoidal approximation method. But the downfall for this is that it doesn't give us exact areas. So right now, we can either find exact answers using geometry, or we're forced to estimate. But the new thing we're going to learn today is that we can find exact areas when we don't have a geometric graph. It just means that we needed to know antiderivatives to do that. Here's how this works. If f is continuous at every point in your interval, so this only works for continuous functions, obviously. If your graph is not connected, you can't find a continuous integral. If your function is continuous and you can find the antiderivative of your function, so big F is the antiderivative of little f, then the integral from a to b of little f can be calculated by finding the antiderivative and this is two steps. So you find the antiderivative and then you plug in the top number first and get an answer. And then you subtract, it's always subtraction, and then you plug in the bottom number. So you're going to find the antiderivative to find these areas of graphs that we couldn't find areas for before. You're going to find the antiderivative, and then you're going to plug in the top number, and you're going to plug in the bottom number, and you're going to subtract. And you always plug in the upper bound first, and you always plug in the lower bound second. So let me show you how this works, because how you show your work here is really important in order to receive full credit, because I need to see your thinking. So if I ask you to find the integral from 0 to 3 of 2x minus 2, now this is a function where if you were to graph it, it would be a straight line. You could use geometry to find it, but since we don't have a graph in front of us, we're going to try to do this using antiderivatives. The first step is going to be to find the antiderivative. So we're going to find the antiderivative by looking at 2x minus 2 and figuring out what would the antiderivative of that function be. The antiderivative of 2x would be x squared, and the antiderivative of the minus 2 would just be minus 2x, and then we're going to have a plus c as a placeholder for some unknown constant. So I'm writing the x squared minus 2x plus c. Now, our rule says we have to plug in some numbers. So to show that we're going to evaluate this function between the lower and upper bound, the way you show your work here is you have to draw a vertical line. That stands for evaluated between. And then you put your lower number on the bottom of the vertical line, and you put your upper number on the top of the vertical line. So that's how you show your work here. Antiderivative evaluated between 0 and 3. Now you're going to plug in your top number first. So you're going to plug in the top number first, which means you're going to get 3 squared, which is 9, minus 2 times 3, which is 6, plus c. So you're plugging in that top number. And then you're going to subtract, and you're going to plug in your bottom number, which means you get 0 squared, which is 0, minus 2 times 0, which is 0, plus c. So you plug in the top number first, and then you subtract, and you plug in the bottom number. And then you just figure out the answer. So 9 minus 6 is going to give me 3 plus c minus, this is just going to be c, which means the c's cancel, so I just get 3. So the area, if you were to graph this and find the area between 0 and 3, you're going to get that the total area is 3. Okay, let's try another one. Number 2 says, find the integral from negative 2 to 0 of 2 e to the x. So step number 1 is going to be to find the antiderivative. The antiderivative of 2 e to the x is going to just be 2 e to the x, because the antiderivative of e to the something is just e to the something, and then you're going to put plus c. Now we're going to evaluate that between negative 2, which is my lower bound, and 0, which is my upper bound. So you'll notice I'm very carefully showing my work. Take this antiderivative, plug in the top, plug in the bottom, subtract. Now I'm going to plug in the top number first. So when you plug in the top number, you get 2 times e to the 0. So 2 times e to the 0 is just 1, plus c, minus, when you plug in your bottom number, you're going to get 2 e to the negative 2. You'll notice that it's going to just be e to the negative 2 because that doesn't simplify. It's not something I know off the top of my head, plus c. And now we're going to simplify. One thing that is going to happen here, which happened in the previous problem as well, is that you're going to have the c minus the other c. So the c's are going to cancel here just like they did in the other problem. We just did it later on in the steps. And so what we're going to get here is 2 times 1, which is 2, minus 2 e to the negative 2, and that's your answer. And the reason that that's your answer is we don't know those values off the top of our head, so we're just going to leave them like that. And that is how you can use an antiderivative. Now, remember, we're still finding an area here. What I'm asking you is how big of an area would be between the graph of 2 e to the x between negative 2 and 0? And the answer is, if you typed this in on the calculator and got a decimal, that's how big that area would be. So you're still finding an area here. We're just using an antiderivative to do that. Let's go ahead and look at some more examples. So the next example says the integral from pi over 6 to pi over 4 of x dx. Step number 1 is going to be to do the antiderivative. Now the antiderivative of x would be x squared, and then I need to divide by 2, so I would have 1/2 x squared plus c, and I'm going to evaluate that between my lower bound, which is pi over 6, and my upper bound, which is pi over 4. And I'm being very careful about how I'm showing my work here. Now I'm going to plug in my upper bound first. So I'm going to have 1/2 times it's pi over 4 squared plus c, minus, and now I'm going to plug in my lower bound. So I'm going to have 1/2 times pi over 6 squared plus c. Just like in the other two problems, because there's a c here and you're subtracting a c, the c's are going to cancel. And so we're going to end up with pi over 4 squared would be pi squared over 16, and times 1/2 would be pi squared over 32, minus pi over 6 squared would be pi squared over 36, times 1/2 is pi squared over 72. In order to make a common denominator here, well, I guess it doesn't really matter. You don't really have to make a common denominator. That can just be your answer. And we can be done. Okay. Next, the integral from pi over 2 to 5 pi over 6 of 2 sine of x. So step number 1 here is going to be to find the antiderivative. So the antiderivative of 2 sine of x would be negative 2 cosine of x. And the reason that this is negative is because the derivative of cosine would normally be negative sine. So you need to make the antiderivative negative. And we're going to evaluate that between pi over 2, which is my lower bound, and 5 pi over 6, which is my upper bound. So I'm going to plug in my upper bound first, which means I'm going to get negative 2 cosine of 5 pi over 6 plus c. And then I'm going to plug in my lower bound. So I'm going to have negative 2 times cosine of pi over 2 plus c. Just like in my other problems, my c's are going to cancel. And so now what I'm going to do is just try to figure out cosine of 5 pi over 6 and cosine of pi over 2. So I'm going to think back to my unit circle. Cosine of 5 pi over 6 would be right here. This is 5 pi over 6. It's one little bit before 6 pi over 6, which would be pi. The point there would be square root of 3 over 2, comma 1/2. And this is going to be negative because you went to the left. So cosine would be negative root 3 over 2. So we would have negative 2 times negative root 3 over 2 minus, now cosine of pi over 2 is right here, which is the point 0, comma 1. Cosine would be 0. So this would valuate to just 0. Now the 2 and the 2 cancel and 2 negatives make a positive, so my answer would just be root 3. For problem number 5, we are talking about the antiderivative of 1 over 1 plus x squared. Now, this is an example of an inverse trig function. In this case, it would be inverse tangent. So we would have tangent inverse of x plus c evaluated between my lower bound, which is 1, and my upper bound, which is the square root of 3. Now that means I'm going to plug in my upper bound first. So I'm going to have tangent inverse of the square root of 3 plus c minus, I'm going to plug in my lower bound next. So I'm going to have tangent inverse of 1 plus c. Just like in my other problems, my c's are going to cancel. And so now I need to evaluate inverse tangent of square root of 3. Now, inverse tangent has a domain restriction where it's only in the first and fourth quadrant. And so inverse tangent is going to be a square root of 3 when the y value is the square root of 3 and the x value is 1/2, which is right here, which is at pi over 3. So my inverse tangent of pi over 3 of square root of 3 would be pi over 3. There we go. Minus the inverse tangent of 1. The tangent is going to be 1 when the x and y are the same, and so that's going to happen at pi over 4. So I would have minus pi over 4. And that means that when I could combine and make common denominators here. So my common denominator would be 12. And I would have 4 pi minus 3 pi over 12, which is just pi over 12. Because I would need to multiply by 4, and I would need to multiply by 3 in order to get a common denominator. There we go. Show all my steps. Okay, next. If we have the integral from 1 to 4 of 4 over x, this is the antiderivative here would be the natural log function. So I would have 4 times the natural log of the absolute value of x plus c. And I'm going to evaluate that between my lower bound, which is 1, and my upper bound, which is 4. Now I'm going to plug in my upper bound first. And so I'm going to have 4 times the natural log of the absolute value of 4 plus c minus, and then I'm going to plug in my lower bound. So I'm going to have 4 times the natural log of the absolute value of 1 plus c. And then I can start to simplify. So the absolute value of 4 is just 4. So I'm going to have 4 times the natural log of 4. I don't need the absolute value anymore because I know that that's a positive 4. I forgot to mention that the c's cancel again. And the natural log of 1 is just 0. So that means that I just have 4 times the natural log of 4 as my answer. Next for number 7. So before I try to do this antiderivative for this problem, I'm going to go ahead and rewrite the original problem as negative 5x to the negative 3. I find it easier to do the antiderivative when I have a negative exponent. You don't have to do it that way, but I find it significantly easier. So now I'm going to add 1 to my exponent. So I'm going to have x to the negative 2, and then I'm going to divide by negative 2, which gives me 5 over 2, plus c, evaluated between my lower bound, which is negative 4, and my upper bound, which is negative 1. When I substitute in my upper bound, I get 5 over 2 times negative 1 to the negative 2 power plus c. And then when I substitute in my lower bound, I have 5 over 2 times negative 4 to the negative 2 power plus c. Just like before, our c's are going to cancel. And so we need to now learn how to kind of evaluate these negative powers. Now, this negative power right here is really 1 over negative 1 squared. So that would just be 1. And this negative power right here is really 1 over negative 4 squared, which is 1 over 16. So that kind of helps me. I convert back to a positive exponent there to evaluate. So I would get 5 over 2 times the 1 is just 5 over 2 minus 5 over 2 times 1 over 16 is 5 over 32. I could make a common denominator here, and then I would have 32 as my common denominator. 5 times 16 is 80, minus 5 is 75 over 32. Last but not least, if we have this polynomial, we're going to start by finding the antiderivative. So the antiderivative, I'm going to add 1 to my power. I make it a 3. Divide by 3, I get negative 2/3. Plus, I'm going to add 1 to my power, so it's x squared. Divide by 2, and I get 6. Minus 17x plus c. And then I'm going to evaluate that between my lower bound, which is 1, and my upper bound, which is 5. When I substitute in the 5 first, 5 cubed is 125. So I have negative 2/3 times 125 plus 5 squared is 25. So 6 times 25 minus 17 times 5 would be 95. I think. Is it 95? No. 75. Okay, I'm just going to do it. It's 85. Oh my goodness. I don't know why that was so hard for me. I'm having a moment. And then minus, it's 85. Oh my gosh. And then minus, I'm going to plug in my lower bound, which is negative 2/3 plus 6 minus 17 plus c. I'm just plugging in the number 1. Now I'm going to simplify. And here's where arithmetic can get really challenging for a lot of students. So I would encourage you to just take it slow. Don't try to rush. Don't try to do too much at once. So I would have negative 250 over 3 plus 6 times 25 would be 150. I think about that because 4 25s makes 100. And you have 2 more of them. So it's 150 minus 85. The c's obviously cancel, just like they did in all the other problems. And now I have to be careful and make sure, this is where a lot of students get stuck. You have to make sure to distribute this negative. So it would be plus 2/3 and then minus 6 and then plus 17. Okay, so this negative 250 over 3 plus 2 over 3 would be negative 248 over 3. And then 150 minus 85 would be, let me think for a second, 65. 65 minus 5 would be 59. 59 plus 17 would be 69, 76. And you could make a common denominator here. If you multiply by 3, you would get, let's see, 18 carry the 1, so 228. So you would get negative 20 over 3 as your final answer. All right. Thank you guys so much for watching. I really appreciate it, and we will see you soon for some practice.